nomine Patris et Filii et Spiritus Sancti. Amen. Credo in Deo, Patrem omnipotentem, Creatorem Caeli et Terrae, et in Iesum Christum, Filium eius unicum, Dominum nostrum, qui conceptus est de Spiritu Sancto, natus ex Maria Virgine, passus sub Pontio Pilato, crucifixus, mortus et sepultus, descendit ad infernus, tertia die resurrexit a mortuis, ascendit ad caelos, sedit ad dexteram Dei Patris omnipotentis, inde venturus est iudicare vivos et mortuos. Credo in Spiritum Sanctum, Sanctam Ecclesiam Catholicam, Sanctorum Communionem, remissionem peccatorum, carnis resurrectionem, vitam aeternam. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. All right, tell you what, take out your notes. I'm going to wrap up the last bit of maxes and mins. The worksheet that's been sort of hovering for a while, I'm going to make due tomorrow just to help a few of the people to catch up. But I want to give you 3 examples. Find the extreme points of the following. X cubed minus 6x plus 2. Have your calculator handy. We're not going to use it yet, but have it accessible. For this first part, I would appreciate if you did not draft this yet. I want to see if we can do it just on our own steam. First, can somebody tell me what basic shape this is? It's a pre-calc question. Go. It's a swerve, kind of, sort of. Maybe. I'm going to get into that today. Can't talk today. I'm going to get into that today. What degree is it, first of all? 3. What's the nickname for a degree 3 function? Degree 2 is quadratic. Degree 3 is cubic. This is a cubic. Would you say it's a positive cubic or a negative cubic? Why do you say that?
Because the leading coefficient is positive.
Right, the leading coefficient, which we call the height multiplier, is positive. This is what we call a positive cubic function. Can somebody remember what a positive cubic normally looks like? Like, how do you draw it? Just a real quick freehand. A positive cubic looks like, how many times would you expect it to hit the x-axis? Yeah, 3 times. So what would it look like? It might be. Here are 3 possible positive cubics. Up, down, up, flat, up, and then a third, which is a little weird, but they do happen, up, wimp out, and up. In other words, it tries to hit the x-axis 3 times. This one is strongest and it actually succeeds. This one is just barely strong enough. It says, it's going up fine, and then go down. I'm so wimpy, I can't go down, and then it goes back up. It struggles for a while, and it says, phooey on this, it goes up. And this one is just the couch potato one where it says, no, I don't think so. I thought about it for a minute, but no, I'm going to go to the fridge instead. So all of these are positive cubics. They all tried to go up, down, up. That's the classic shape for a positive cubic. I want to see which one this is. The reason we're worried about this, Montessori madness. I hear somebody think, I said, yeah, good luck with that. So why do we care about this? Are there any maxes or mins in there? If so, what? Nate? Like what kind?
There's only locals.
There's only locals, and what kind?
There's a local max and a local min.
Exactly. There's a local max and a local min. What about this thing? Anybody? extreme points? No. This is not a max and it's not a min. It's a weird point, which we're going to actually talk about. Technically, we were supposed to talk about it next chapter, but I'll give you a little teaser. Any maxes and mins on this one? Like, heck no. It's not even trying. Right? It sort of drifted in one direction as if to try and have you ever seen your siblings, or maybe on a bad day you know, mom says, hey, can you take out the garbage? And you're going to do whatever you wanted to do. Oh, yeah, sure. Whatever. It's like, well, no, you didn't even try. You drifted for, 2 feet in one direction to kind of, like, who did you fool here? Yeah, Mom, I'm going to go get the garbage. Oh, there's the garbage. That's nice. But that's what this is doing. This thing, at least, I got to go get the garbage. Yeah. At least it stopped for an instant and contemplated it before it gave up. And this one actually went, okay, I better go back and get the garbage. Okay, bam. Okay, so the only one that's going to give us maxes and mins is this. How do you find it? We're not graphing it yet. How do you tell without graphing whether this thing has maxes and mins? Where would you find them? Like, how do you find the x values of where maxes and mins are? Go, yeah.
Derivative?
Derivative, okay. For example, f prime is what in this case?
That's 3x squared minus 6.
Interesting. What does the first derivative do? What does it give us, Mary?
So tangent
The
slope.
tangent slope, exactly. And why should we care about the tangent slope if we're trying to find maxes and mins? Go, John.
Isn't the tangent slope 0 at the maximum?
If you have a max or min that's a nice smooth one, the tangent slope is going to be 0. There are 2 possible values of a derivative at a max or min. Did somebody name them? You named one of them already. Go.
0 and undefined.
0 and undefined. Right. 0 is the nice normal smooth ones where it just goes up, glides down and such. Could you have a max or min at a place where the derivative is undefined? Yeah. Yeah, you could. I'm going to talk more. Again, that's coming up more next chapter, but I'll give you a teaser now. For now, set this equal to 0 and see if we can find any. Blades, help me out. Solve this for me. Just ignore the thing. Okay, so 3x squared equals 6. Divide by 3, so x squared equals 2. What would you get?
Positive or negative radical 2.
Exactly. Plus or minus square root or radical 2. So on a graph, by the way, radical 2 is approximately 1.4 something. 1.414, blah, 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 blah. A little less than a 1.5. If you wanted to mark it on a graph, it's right around here. Put a little dotted line. This is not an asymptote, I'm just marking it. So there's like 1, here's 2, negative 1, negative 2. So somewhere along this, this is radical 2, this is negative radical 2. Somewhere along this line, it's going to hit a max or min, theoretically. I do know that somewhere along this line, the slope is 0. If you go over radical 2 spaces to the right, the slope is 0 somewhere. Given this, and given these pictures, can somebody kind of reconstruct on this left-hand one, every 0 pointing? Is that going to give us the max, or is that going to give us the min? And tell me how you know. Sam. Okay. Yeah. It's going to give us the maximum. What told you?
Well, it's a positive cubic. So
Yeah. The max happens first. This. Whichever, I'm just reading from left to right. I have no idea, like, this is just a little freehand thing. I have no idea where this is, no idea where this is. But I know the max hits first, then the min, and then it takes off. The max is going to be here. The min is going to be here. and it takes off. I don't know how high they are. We'll find it out in a minute. Speaking of which, how do you find the heights? Like, I know that the maximum is going to be at negative radical 2 comma something. And the minimum is going to be at positive radical 2 comma something. See where we got that, first of all? I got that from here. The first event that happens is it's going up and hitting a maximum and coming back down. So it's negative radical 2 comma something. Tell me how to get to something. Back up.
You just plug the X in.
Plug, exactly. Plug it in where? I see two equations.
The first, the not the derivative.
Correct. This is the height equation. Because f of x is also called y. This will not give you the height, this will give you the slope. So plug it in this original one, and it'll look like this. Negative radical 2 cubed minus 6 times radical 2 plus 2. Can somebody simplify that for me? I would not use a calculator for this. This is just, it'll give you some horrible decimal. Let's see, Nate, take this one. What's a negative cubed, first of all? Positive or negative?
Negative.
Negative. Negative what?
It's going to be negative 2 radical 2.
Very good. Negative 2 radical 2 plus negative 6 radical 2 plus 2. Go for it. You can have two parts.
Negative 8 radical 2 plus 2.
Right. And I'll do the 2 plus negative 8 radical 2. We'd like to put the nice part first and the inky part later. You just found the max. And it's a pretty disgusting looking max, but you don't have to graph it. Just plot it. As a matter of fact, this is much easier if you don't graph it. Just be aware, 2 plus negative 8 radical 2, just for fun, grab a calculator. Yeah.
Right, so when you're inputting in them, you had, in that first parentheses, you had negative radical 2, in the second parentheses, you inputted radical 2.
No, good point. So that would be plus. So yeah, sorry, my bad.
Nice.
Good catch, thank you. Just about went off a flaming cliff. So it would be what? 4 radical 2. Good. Take your calculators. That was actually a life-defying, death-defying moment. I was like 1.5 seconds away from saying type in negative 8 radical 2. Thank you. Type in 2 plus 4 radical 2. Anybody know where to find the radical? You have to hit second and then hit the x squared key. Have we got it? How much? Somebody give me a decimal to 4 decimal places. Have we got it? Go.
You said to 4, this one? You said to 4, right?
Yeah, correct.
7.65679.
Correct. It's approximately 7.6569. That means over here, this is 2 plus 4 radical 2 here. Can somebody find the other one? Again, on your test, and it's very, very unlikely you'll have to actually graph the max and mins. Sometimes, maybe one problem you will, because it takes a while. Find the min height for me. How do you do it? Go.
Is it negative 2 minus 4 radical 2?
Maybe. How do you find it?
It's just the opposite.
What do you plug in?
The y. I'm plugging radical 2.
Right. It's going to be regular radical 2 cubed minus 6 times radical 2 plus 2. And you might be right. This is 2 radical 2 plus negative 6 radical 2 plus 2. So there's going to be one tiny difference. What's the, so it's going to be 2 plus what?
Minus 4.
Negative 4 radical 2. You could also write it as 2 minus 4 radical 2. Ever recognize that? That's the what of the first. It's a conjugate of the first one. Correct. So the one over here, 2 minus 4, type in 2 minus 4 radical 2. A lot of people assume, like, in other words, this thing was approximately 7.6569. A lot of people assume that the other one's going to be negative 7.6569. What'd you get? Have we got it? Good.
Negative 3.656.
Correct. This is 2 minus 4 radical 2, which is approximately negative 3.6569. Same decimal at the end, but very different. So it goes up a lot higher than it goes down. Can somebody tell me the y-intercept, by the way? Where's the y-intercept? Just look at it. Here's the original formula. Yeah, good. Yeah. Okay. Yeah. 2. Plug in x equals 0, and you have y equals 2. You've actually got a fairly good graph of this thing.
Oh,
Does that make sense? Eventually, a lot of the stuff that we're doing is aimed toward making a very accurate graph. We are eventually going to graph. I might say here, use calculus to make an accurate graph of this. We can make a much more accurate graph of this than we could in pre-calc. Pre-calc, we had no idea what a derivative was. All we could find were the x-intercepts, there are 3 of them, the y-intercept, and then use a chart. And on a chart, you would have probably missed the 2, like the per 10 vertices, the max and min. We would probably have missed those because they're not whole numbers. If you're doing like negative 3, negative 2, negative 1, 0, 1, 2, 3, you would have completely missed these. In calculus, we can now nail them, and we can have a much more accurate graph. Does that make sense? All right, write down the next one, example number 2. Find the extreme points. Find the extrema, basically. G of x equals, actually I know this one. X cubed plus 3x squared plus 3x plus 1. Go ahead and do that one. Where would you start? Now you can skip any steps you want as long as you get the steps we need. Go.
you take the derivative. Right?
Definitely. You can take the derivative right away. What is the derivative?
So it's going to be 3x to the second plus 6x plus 3, 0.
Yeah, y equals 0. What does that do? We don't do it automatically.
Finds the tangent slope.
Yeah, I want the tangent slope to equal 0. That'll tell me all the places on the graph where the graph flattens out. Can somebody solve that for me? This is actually a first-year algebra problem now. Go.
Take a GCF of 3.
Right. So 3, then parentheses what?
X plus 2x plus, x squared plus 2x plus 1.
Good. Does that factor?
Yes, it's isn't it just x plus 1 squared?
Yeah, that's a difference. That's a binomial squared. Square the first, double the product, square the last. Solve. And by the way, if you do this, it's perfectly okay. It's the exact same thing. What solutions? It might even be easier to look at it this way. What solutions do you get? Mary, help me out.
Negative 1, 1. I mean, negative 1 to negative 1.
Interesting. This, if it were a regular graph, that would be called a double root. This is what we call a double extremum. We've got a max and a min in the exact same spot. That kind of makes the graph go psychotic. It's kind of like saying, I want this to be the best you've ever been. I also want this to be the worst you've ever been. So what do you want me to do? Be both. So here's what it tries to do. What this thing wants to do is glide up, then glide down, then glide up. That's a normal cubic. It hits a max, then a min, then it keeps going. This is, let's say this is like x equals negative 2, and this is like x equals 2. So if you have like a graph like this. What if you moved these closer and closer and closer together. And then closer. And closer. What if they're on top of each other? That's what causes a swerve. If you remember, a triple root causes a swerve. And I have a secret for you. This is actually x plus 1 parentheses cubed. There's a triple root at x equals negative 1. So this thing actually looks like this. Go up, flatten out, up. That's an actual swerve. So technically when you run into a positive cubic, it's not necessarily a swerve. Only one of the three gives what we call a swerve, like a triple root swerve. And this one is one of them. So what do you think? Your prediction, where are the maxes and mins? Yeah. Kind of. Is that a max or a min? So what does that mean? Hold on. It's kind of like first year algebra. Whenever I introduce no solution, I'm scared to death because people start putting that on all. This is a hard problem. No solution. Like, no, it doesn't mean hard. It means like it means something. Yes. What? Nailed it. What was it? They cancel each other out. I just realized that this is off screen. Hang on a second. For you poor souls listening at home and wondering what on earth I was doing off screen, I'm terribly sorry. Here we go. Let me point this stuff out. This is the other problem. Here is the original problem. X cubed plus 3x squared plus, we haven't done any calculus yet, so don't worry. So I wanted to graph this eventually, but I don't know how. We took the first derivative, set it equal to 0, and we know there's going to be a max and min at -1 and at -1. Now the traditional cubic goes up, then down, then up. Max, then min, then up to the great beyond. Both the max and the min are happening at the exact same point, which basically means they cancel each other out. There is no maximum, there is no minimum. It flattens out for an instant and then goes up on its merry way. Does that make sense? So there is no max and there is no min. Whenever you have a double extremum, an extremum on the same spot, they cancel each other out. Does that make sense? All right, maybe we can tip this thing back to its normal spot. So let me see if you can do this one. Example number 3. Should be the last example of the day. And then we'll take a look at the worksheet. Example number 3, try this. H of x is equal to x cubed plus x plus 2. Go for it. I want to find the maxes and mins. Any broad ideas? Go. There. Take the derivative. What is it?
3x to the second.
Uh-huh.
So
Plus 1. So how do you find the maxes and mins?
7 equals 0.
Right. Set equal to 0. Again, later on, I said there are 2 types of derivatives that could possibly make maxes and mins. 0 and undefined. We've really not touched undefined derivatives yet. That's more next chapter. I'm just giving you a teaser for this chapter. But for now, find the 0. Solve. Go for it. What would you do first?
Add the 1.
They add.
Subtract.
Subtract. So what do you get so far?
3x squared plus 1.
Equals -1. Okay.
Divide by 3.
Okay. I'm wondering if anybody can see what's about to happen. Now what?
Square root both sides.
You're going to square root both sides. X equals plus or minus the square root of -1/3. Anybody know what that is? How do you square root a fraction? Square the square root at the top, square root at the bottom. Do it. What's the square root of negative 1? I over radical 3. What kind of a root is that? Or a solution, I mean? Oh, yeah, definitely. But is it real? No, it's imaginary. It basically says it hits a max at an imaginary point. It hits a min at another imaginary point. What does that mean in real life? It doesn't. It doesn't even flatten out. This, it had a max and it had a min and they just beat each other up. This one, it doesn't even try. You've just run into a problem like this. It does a gentle swerve and just sort of says, it sort of swerves just long enough to wave and then abandons you. No max, no min. Okay? Any questions on this? So every once in a while, if you try and find maxes and mins, set the derivative equal to 0 and it blows up in your face, that probably means there are no maxes and mins. Make sense? All right, are there any other problems on the worksheet that you would like to pound out? Otherwise, I'll give you the rest of the hour to pound away at that. I do have the next worksheet for people. It is not going to be due tomorrow, it's going to be due Friday. I'm going to run down and grab that soon. But any questions on, oops, the current worksheets? Speak now or I'll assume you've mastered it. You know, about to sneeze, hang on. Oh, I hate that. Okay. I think every time I uncap a new marker, it's like I sneeze and then sometimes they get trapped. Annoying. But I'm listening for questions. No questions? Everybody okay on doing this stuff? All right. Well, okay. I will say you can graph these things on your graphing calculator. Just be warned. If they're looking for maxes and mins that are exact, like this, I would not accept 1.4142 as a good answer. I want radical 2. I want the exact answer, not a decimal round off. So make sure your calculator is not betraying you. There are a few of these on the 3H-1 that do have radicals in their answers. Not many. I think there's only one of the 6 problems that does that. One of them is a fraction, so repeating decimals, I guess, are okay. I'll bite my tongue and accept them. Most of these are going to find absolute and relative maxes and mins at relatively nice numbers. There's one with a no. There are 2 of them with fractions in them and 1 with radicals. And that is all I have for you. Any questions? All right, so 3H-1 will be due tomorrow. That's all I have for you. All right, so go ahead and get busy. I will run down and grab the next one, which I think is 3H-2. And we'll be right back.
Honestly, Josh doesn't looks like it's correct. No way. Figure it out. I'm happy to see it. You can see other numbers. He's gonna ask you to show work. Yeah, but I can't. If it's not that complete, show.
any derivatives? Ignore that.
The next worksheet, did I turn that thing on? Oh, oops, I didn't. Anyway, sorry, that was, you can fast forward. It's too late now, but you could have fast forwarded over the last 2 minutes, sorry. Anyway, God bless, heal well, and we'll talk to you soon. Bye-bye.